So basically what I want to do today is go through some examples and some context to sort of look at how these large language models, so-called, which have dominated this discussion for the last year and a half, how they work and what I think is required of us theoretically from the standpoint of cultural theory, philosophy, to make sense of them. And in particular, I want to make the case that they realize a point of view about language, which is called structuralism, and that they strip that view of any of its cognitive counterparts. And so they realize like a type of real language that nevertheless has no human cognition or intelligence attached to it in a really kind of bizarre way. And that is the basis of so much of what we're seeing in AI going on around us, and thus needs a lot of attention in the present. This work is coming from a book manuscript, which I've just finished and which is going to come out next year in early 2025, which is called Language Machines. So I think this is the first talk I'm giving, having the full manuscript in hand. So 2023 saw this, what I call like a panic hype cycle in AI. And I think that this type of thing has happened countless times in the past. You can look to popular magazines, Time, the New York Times in the 50s even, but you can see it sort of unrolling and getting faster and faster, where what happens is basically some new technology that claims to have some spark of intelligence in it comes out. It gains some ability that machines, computers, algorithms, whatever you want to call it, didn't have before. And then initially there's a sort of a lot of hype about it. The line is usually that some form of what we now are calling artificial general intelligence, or AGI, is sort of like on the horizon, or it's already been achieved. And then there's a panic about it. What if the machines harm us? What if they kill us? What if, and so on. So this, I think 2023 has been the largest panic hype cycle in the history of AI to date, and it's not even close. We saw effective altruism backed. That's a movement in philosophy and ethics. Statement published and covered in the New York Times about mitigating the risk of extinction because of AI in reaction to ChatGPT. Really, we saw Henry Kissinger before his untimely death claim that these systems know more than humans do about the real world. And we saw a major reaction come from a group of AI ethicists who focus on harm and the worry that these, what they called stochastic parrots that imitate human speech, but then just sort of remix it, statistically, will amplify and exacerbate problems of bias, racism, and inequality in our social systems. We also saw, and I thought this was one of the more interesting contributions this past year, Matthew Kirschenbaum, the media scholar, claimed that these systems really had the ability to plug into the textual environments that we all live in, these sort of massive digital textual environments that run on plain text, and altered their nature of those environments, and that this would be the actual danger that emerged from them. And so we see, and this would be, I think, in keeping with Matt's notion of the textpocalypse, things like on the top left here, entirely fake personas, not reporters that don't exist, writing articles that are penned entirely by bots. In this case, for Sports Illustrated, they were caught. I'm not sure that they're still doing it. And then the rise of the peer-reviewed scientific paper that has watermarked, like obvious, like metaphorical watermarks that show that it was generated by a bot. Like in this one, from Surfaces and Interfaces, the first line is, "Certainly here is a possible introduction for your topic." And there was a very interesting, I might come back to this at the end, observation, which is that scientific papers have seen several orders of magnitude, like thousands of percentages more use of the word delve, which we know is one of ChatGPT's preferred words for thinking about, researching a topic or getting into a topic in the past 6-8 months. And so there's a suspicion that ChatGPT is being used in these settings where we would think that it shouldn't be used. Why shouldn't it be used? Because, of course, these systems hallucinate, so-called. They produce, by generating the next word in a sequence, they probabilistically predict what might happen next in language. And so they tend to produce results that we don't think are grounded in our realities, and that is one of their main dangers. So we've seen this sort of panic hype cycle rise around this, but we've also seen the enmeshment and the sort of embedding of these systems, not just in educational systems where there's been lots of worry about like the end of the student essay and the end of writing and so on, but we've also seen them now become used in places where we suspect that this might only be the tip of the iceberg, that the usage is actually much higher, that a massive amount of bot-generated text is already circulating on the internet, and which has led some commentators to call that the pollution of the internet. I did not become convinced that something interesting was going on in 2023, however. I became convinced that something was going on when I read this text, which came out in 2019 and was produced by GPT-2, the predecessor to the underlying model that ran ChatGPT when it first came out. This text, also from OpenAI, which runs ChatGPT, is a prompt was given to the system telling it that a scientist had discovered a herd of unicorns living in a remote, previously unexplored valley in the Andes Mountains. The system then responded with a completion, which is formally or generically, let's say, a science reporting article. There are many mistakes in it, or actually there's only a few mistakes in it, but at the level of its overall general form, it had responded with what is indeed a science, like a science reportage article, complete with quotation marks, complete with a consistency across many of the names that are found in there. I suspect that they had in mind Arthur Conan Doyle's The Lost World, in which scientists discover unicorns, and in which scientists discover dinosaurs in South America, and which may or may not have been a predecessor to Jurassic Park. In any case, what I found interesting about this was almost the opposite of what other people seemed to think about these models, or seem to think now. So because the models hallucinate, there has been a debate about the problem of what's called symbol grounding. Like, the models produce a discourse, they produce an article, they produce a text, they produce an essay of some kind, and the question is, and then obviously they're unable to, they don't know anything about our world, so that text is unrelated to our world. It's not grounded in the terms of this old debate. And Yann LeCun, who's here at NYU, is one of the founders of the modern version of these models. Has argued that this is because they're not grounded in sensory perceptions, that the models they only have access to language. Because they only have access to language, they're not able to verify their linguistic constructions by reference to some sensory information. Unfortunately, this is not actually a great way of evaluating what the models are doing, because this text, for example, is about unicorns, and no one has ever had a sensory grounding of a unicorn, because of course unicorns don't exist. So the problem of the grounding, the problem of truth in these models, has to be located somewhere other than in the place where sort of we tend to locate it, although I think that it is naive when we do so, namely in the human cognitive apparatus, including the brain, the sensory information that we have, and so on and so forth. The other thing that I want to point out about these models is that the language models themselves, which are not creating things from a cognitive apparatus that is grounded in sensory information or whatever, are at the basis of so many other uses of AI right now. So we have seen those from these somewhat trivial and amusing examples, the Mona Lisa fill, the creation of a sort of background for the Mona Lisa, to what I call thick Descartes, this image which I suspect actually a human made and then pretended as an AI. images are now being generated on the basis of this use of language. Literally, the large language model is being used to create these images. And in so many other applications, protein folding, targets for war, like the ongoing war in Gaza, and other places, we're seeing these specific large language models being used to generate predictive tokens that then are used in one way or another in whichever domain they're in. So that this, whatever is happening in the language model, and I fully agree with Jan here that it is not sensory grounding, whether sensory grounding exists in general or not, are being used to create all these other effects. So we're getting a sort of weird spread of large language model into many other domains, language being used in all these other domains. So what I want to do with the rest of my time here is just to describe a little bit how this works in such a way as to go back and suggest something about what this world that's filled with algorithmic language, how we might approach it. So the underlying architecture for all of the models that so far exist of this kind is this thing called the transformer architecture. And the center of the transformer architecture is the attention mechanism. You can see it in the middle on this diagram. The diagram looks complicated, but we don't need to explain the entire thing. What's happening is that in these models, we are training a model to be able to predict the next word in a sequence over a very long sequence, sometimes thousands of words, depending. And we are pre-training the model on, in the case of these so-called large language models, trillions of tokens. So we're taking text from the internet, and we are taking the speculation is that it's now up to 5 or 6 trillion tokens in the pre-training corpus, and we are feeding it into the model. And two things are happening when we feed that in. One is that a vocabulary is established by a tokenizer. The tokenizer is basically taking all the words as they come in and basically just assigning them to single numbers, single integers, basically. Every time it sees the word fine, every time it sees the word elbow, every time it sees the word banana, it puts it in that bucket. And there are some things in there that aren't words, right? Like little fragments of text, adverbial endings like li and ing and things like that. But we can think of that mostly as words. And once this tokenizing task is done, the tokenized vocabulary is then used to establish the model. But the way that the model is trained is that the entirety of that 6 trillion or 5 trillion, all those tokens are passed over the vocabulary in such a way that they gain a relationship, each one to every other one. And this is just held in a matrix. And the matrix is, in the case of GPT-3, the matrix was about 50,000 tokens, or that's its vocabulary size. So that's the thing that's allowing this all to happen. And I just want to say a few things about that thing and then open it up for discussion. So the predecessor models to these, which sort of led in the direction, the intuition that engineers had, were these things called vector semantics models. And what they were able to do with vector semantics is that they were able to take a vector. All the words are translated into like vectors in the sense of just numbers laid out in a, right, let's say, open bracket 2, comma, -5, comma, -3.2, comma, 12, end bracket. Each vector like that is laid out, and when you multiply them together, you can create a vector space, and in that vector space, things that are semantically close to one another end up being mathematically close to one another. So you can see here that analogies between capital cities, analogies between activities were established successfully by this. So you had, and the famous example that was always used here was king minus man plus woman equals, and the vector that you would get from that would be queen. And Gianni Gastaldi and Luc Pellissier have argued that this kind of realizes this notion from structuralist linguistics, which is the notion of a paradigm, the notion that when you say, for example, the word kid, there's a series, a kind of a vertical series of synonyms that you could choose from: kid, youngster, tot, infant, and so on, right? So this was all achieved right around about 2013, 2014, and there was a lot of hope for these models. But what has happened since then is so much more powerful. These models were able just to sort of show a little bit of semantic density, to sort of correlate terms with one another. What we have seen with the large language model is something much, much more powerful, which, as we saw at the beginning, can write a whole article about fictional unicorns and keep to a kind of generic template for what that article should look like, while actually being correct at the syntactic and even at the semantic level to a large extent. And so what it does is it realizes, instead of creating just a paradigm, it also creates a sequence of words. And that sequence of words, which in structuralist linguistics was called a syntagm, is sort of that sequence could be anything. So we hear all the time that these things are just next word predictors. And I really object to this phrase, because I think that deciding what the next word is actually incredibly complicated, and we don't know in advance what is happening when we select a next word. What will be the correct next word cannot be derived by predicting that from, for example, a physical situation that someone is in. It can't be derived by sort of spying on their brain. It can't be derived from anything else. In fact, the next word contains the structure of language itself in some meaningful sense. There are, to my mind, three major proposals right now for where meaning comes from in language. And one is a statistics proposal that dominates in natural language processing and in data science. Its maxim is, you shall know a word by the company it keeps. That's the vector semantics model. Look how close these things are to each other. Look how often they are distributed together. Then you know what the word means. The other one is Noam Chomsky's idea of syntax, a sort of like cognitive operation that imposes structure on language from, probably, according to him and his school, a deep seat in the brain. And the third one is a semiotic proposal, a proposal that comes from Ferdinand de Saussure originally, the structuralist proposal. And the thing that I want to emphasize in this proposal is that for the structuralists, language is first complex, and only afterwards does it become simple, or does it become singular. So when I say a word like elbow or unicorn, and I reference that thing, I make a reference to the thing. The idea from the structuralists is that I am activating quite a bit of complex structure, not that I am instead, starting with the simple thing, and then I will work up to the complex thing. And I think that this like culture first complexity is what's realized in this system. So in last couple of notes, and then we'll go over to conversation. Saussure describes that process. These are sort of famous images from Saussure, which you may or may not have seen before. He says that every sign, every linguistic sign, is divided between a signifier, which is like a vehicle that signifies, a material vehicle of some kind, and a concept, the signified. And he says that language together is all these signifieds and signifiers operating in tandem as a totality. And he says something rather surprising. He says that when I refer to something, when I say, here is an elbow, here is a unicorn, whatever, I am signifying that thing. But the meaning of the words does not come from the reference. The meaning comes from the way that the whole thing hangs together. And so he says, in language, there are no positive entities, but only differences. Only differences, and then the differences make up the specific references, the specific changes that we get at the local level. If we go back to the attention mechanism, and I won't go into this in depth unless somebody asks me a question about it, but here is a real bit of training data, which says this is German, happens to be German, without registration for free, play a lot of browser games online now, and then a sort of string of kind of HTML mock-up nonsense language. That string, just as it is, passes over as a sequence each token. So once everything has been tokenized, you have to imagine trillions of words all being fed into the mechanism like this string. Now think of all the websites out there. Think of Reddit, think of Wikipedia, think of books corpuses, think of many, many other things of this kind, right? And each sequence is passed over, but as a sequence, that underlying model which has all the words in it. And those words then slowly over this entire trillions and trillions of trillions and trillions of words in these sequences are being passed over it, create a sort of relevant structure to each other. And in the creation of that relevant structure, that is, if you look at this sort of image on the bottom right here, just a light grid. Every time you say in a given context, what is likely to come after this word, what is compared is all of that linguistic structure that's been extracted with the vocabulary set. And so in a way, what we get is, in these models, a valuation of local entities within language from a much larger, unimaginably large, just massively large training set. And that training set sort of determines the local values. Now, there's been a lot of attention to these systems, and there's been a lot of talk that these are not really producing language, that what they do is not real language. Some critics call them synthetic text and so on. But we see here that they are really achieving not the cognitive aspects of language, but the extensive structural aspects of language by creating value in language and changing the value, the actual meaning of words. So in the case of that word delve, which has been overused by ChatGPT, the controversy around it has led people to reconsider, should I use the word delve when I am typing, into my academic article here? Perhaps not. And interestingly, part of the reaction to the revelation about that word delve was a series of Nigerians who saying the word delve is very important in Nigerian English. That matters because some of the training that these models undergo is with humans in the loop, and that training has been offshored in many cases to places like Nigeria. So there's a suspicion that what we are seeing there is a lock between algorithmic language and human language, which in this case produces a sort of negative effect on the value of a word. So we see them plugging into and realizing this structural and, in this, so far at least, non-cognitive aspects of language. And I think that in order to study such systems, we need to reactivate parts of the structuralist paradigm in order to make sense of what's going on around us, not just in web text or whatever, but as we were seeing before, in images, in war, in strategy, in business, in spycraft, and other places where AI is used today. I'll leave it there. Thanks.
Brilliant. Thank you so much, Leif. I'll now hand over to Audrey, who will be in discussion with you for a little bit.
Few minutes. Thanks, Andres. Thank you so much, Leif. It was really interesting. I love it when you say the next word contains the structure of language itself. It sounded very Leibnizian, kind of quite monadic, and in a way, actually, it makes your point very well, especially for that kind of the monad of the self-contained monad that would reflect within that structure on itself, would reflect the meaning from a different perspective of that sequence of tokens. So something that you've mentioned, and I was thinking, so the word ersatz came up in my mind. I mean, you started this talk with the idea of the scientific articles, and how now we have this kind of overload, and we're drowned out by all of these various articles and obviously fake news, but including in the realm of science, we've got material and facts that they look real, they feel real, but they aren't real. And I've been wondering, the word that came to my mind was the word ersatz, which led me then to thinking about mimicry and Turing. And I wanted to ask you whether to what extent, you know, we've overcome maybe Turing and then the famous 1950 paper and the Turing test, and the idea that once we have mimicked, you know, we have successfully, well, so-called successfully, once a machine has so-called successfully mirrored our language, then it can be considered intelligence. Do you think we've overcome that paradigm and that that idea, and that the framing was wrong, that we should adopt a new framing?
Yeah, I mean, so Turing in 1950 proposed this test based on this parlor game, right? The parlor game is, you know, two people go into different rooms. One is a man, one is the one is either a man or a woman, and the one in the other room has to guess based on textual transmissions, basically passing notes back and forth between the rooms, which gender they are. And Turing suggested that if a machine could fool you into thinking it was a human more than a certain percentage of the time, really the idea was very loose, though. He just thought at a certain point, you know, it no longer makes sense to say this isn't intelligent. It only, you know, and I mean, I think Turing was a very sophisticated thinker about this problem. I think he thought we don't, as humans, demand any mechanistic knowledge of someone else's intelligence. I don't say, Andres, let me see inside your brain to make sure that you're intelligent. Of course not, right? It's a sort of affordance. It's a social affordance. I do think, however, that Turing didn't think, and there are these wonderful sort of like fake dialogues that he wrote that don't really exist, right? They're just sort of, you know, here's what a machine could say or might say, right? But I do think that there's been a sort of slow process. You could just see the whole modern history of communications media this way, of taking things that we think might be like just human abilities and externalizing them, or making them tractable using some sort of machine or eventually some sort of computation. Computation itself is one such thing. I think we would have thought a few hundred years ago that only humans could do math. But it turns out that we've created a kind of, you know, way to externalize that characteristic. I think that, you know, images also went that way about 100 and a few years ago. And I think that language is the hardest blow in a certain way. I think it's entirely shocking to see language become algorithmically tractable, and that it's basically unacceptable to us at some level, and that Turing did capture that. Turing also suggested that he says in the 1950 paper, it's possible that the way that we're going to get where we need to go is not by imitating humans, but possibly by doing some other thing that gets us to intelligence by some other means. And then he sort of dismisses it. And I think that's relevant today because for a couple of different reasons. I mean, I think now we see, I think many of the greatest successes of artificial intelligence, well, successes, whatever, however you want to see them, you know, sort of normatively, that the greatest advances in artificial intelligence have been non-imitative. They haven't been imitations of human abilities, although they arguably merge with human abilities in some way on the other side of the process. There's an economist at Stanford, Eric Brynjolfsson, who coined this term a couple of years ago, the Turing trap, to describe exactly this problem. And I think it's really significant for evaluating the social ramifications of these systems, because it's often the case that we pay most attention to the places where they're imitating us, and then we don't pay attention when they're doing something which can be far more influential, insidious, powerful, you know, whatever. And I think that LLMs are kind of in a weird case of that, because in the case of language, we tend to just sort of look past the language. We don't pay attention to the surface of what's going on. So we see a lot of people saying now, well, you know, they don't tell the truth, they hallucinate, they do this, they do that, they can't do math properly, et cetera, okay? But those same economists and people in business schools are now showing that the least productive workers match the productivity of the most productive workers when given an LLM and trained how to use it within just a few months. So there is going to be a transformation of knowledge work. I don't think that it will come for, you know, books about Leibniz or writing, you know, like, you know, poetry or anything like that. I think it will take the most mundane forms of knowledge work and make this thing into something you have to engage with, just the way 30 years ago, you had never seen an Excel spreadsheet unless you were in a very rarefied area of work. And now almost no one works without Excel spreadsheets within certain sectors of the economy, right? So we're going to see this sort of transformation happen, and probably a lot less hype around the methods at the same time. And I think we have to stay focused on what's actually going on. That's kind of the thing that I'm trying to push for here, at least.
Thanks for that. I mean, can you agree that perhaps on some level, telling us about languages that are not attached to human cognition is a bit strange? That we've got languages that are no longer grounded in our realities, as you mentioned at the beginning of your talk.
Yeah, I think it's super strange, and it's super fascinating. Yeah.
And that, yes, it is a very weird position, uncanny. I mean, I don't really know what the term is, and I think you grasp it well that we can't really, describe. It's completely unprecedented, as you write in some of your articles. I mean, what do you think the implications are of that we've got this non-cognitive language / languages? I mean, obviously, we don't really know what's going to happen on that level, that create meaning, but that are no longer attached to some kind of idea of truth, capital T? Or did we have this all wrong from the get-go? This idea, this erroneous, where we're wrong all of this time, where all of these philosophers going back centuries, where we're completely wrong to in reifying and essentializing perhaps some of the idea that there was a truth, and that maybe our linguistic realm was inevitably, hopefully, attached to an idea of a truth that we all shared. I mean, were we wrong there too?
Yeah. Well, I mean, this goes to the heart of, this is one of these debates that has happened in philosophy over the last 100 years, right? I mean, and I think that there's a kind of weird thing happening now where we see, like, both politically and also at some level academically, there's a kind of backlash against what was called literary theory. Not so much in the Saussurean model that I was talking about as in the next stage, which was called post-structuralism, and which indeed said very radical things like authors are dead, there's only the text, there's nothing outside of the text, and so on and so forth, right? And these things seem relativist or to undermine the notion of truth or whatever, right? But in many ways, I think they're just diagnostic. So you could say, rather than seeing someone like Jacques Derrida as a terrible or great, knight on horseback for relativism or something, you could say what's being said there is the cultural web, the density of language through which any truth is achieved, is truly thick. And it is not simple to say what we should think, grounding is, for example, right? And I think that, like, in many ways, like, those of us who are trained in those methods just see them reflected in this, like, larger social condition now, especially when you extend it, with using computation and into a kind of global infrastructure. So you look at all that and you say, now a conversation emerges about misinformation. Well, that conversation was being had by literary theorists who, granted, in many cases were not really serious about diagnosing that more beyond a certain sort of stance or posture. But nevertheless, I think there's a sort of like kernel to that I think is really important. Now, does that mean that I think that the notion of truth is undermined by LLMs or ChatGPT or whatever? Of course not. That would be like a completely absurd thing to say. What I think is going on is you take a simple idea or a simple notion of cognition. I think the reason I beat up on Jan here a little bit is that Jan is basically saying something that is sort of like a vanilla version of something that cognitive science likes to think, although it's certainly not the only notion out there, which is like we developed brains in evolution. The brains deal with information in a certain way. The brains then start to develop, they have rules, right? There's some sort of like computational, language of the brain. And then we translate that outward into like artifacts. We make technology, we make systems of things like language. And then, but those things, don't worry about those things. That's just culture. Don't worry about that culture stuff. That's real complicated, but it doesn't matter because it's not a serious object of science. Well, I don't know if it can be a serious object of cognitive science or not. There's a whole debate about that. But is it a serious object of our knowledge of the world that we live in? It always has been, is what I'm trying to say. And now it's running on these computational rails. So the question becomes, how do language and mathematics sort of get along in this form? How come those two systems are interoperable? And that's the question that I'm asking in this book, which is basically like, how do you conceive of those two things actually merging and sort of getting along at a formal level as systems of representation? There are some answers that have been given to that question, but typically we've always had this truth question in the background. And the truth question has run through a conception of human knowledge. And there's a weird way in which these systems produce really meaningful stuff, not necessarily stuff we like, sometimes biased, sometimes worse things, whatever, but they produce meaningful stuff. And we need an account of why that meaning is possible in the first place. And I don't think that that account can really come from knowledge of human thinking. It has to come from knowledge of the extensive ways in which these systems are actually interacting with each other, like out there in the world, basically. Yeah, does that?
Yeah, sure. Computational systems and culture.
Yes.
Yeah. So, but I didn't hear the magic word in any of your presentation, Leif. Leibniz may not be important, but what about Husserl, Hans Blumenberg, and their concept of life world?
Oh, the life world. Yeah.
Realms. And similarly, they put aside all of this, the thorny ideas of intelligence and cognition and origin of human thinking and truth, capital T, to just say, these are the values, these are the meaningful realms in which we live. Do you think that now is a good time with the rise of generative AI to perhaps, re-embrace this concept?
It could be. I think it could be very valuable. I have a little bit of worry about the phenomenological strain of this thinking for the following reason. So I have an article floating around out there about Blumenberg and his one commentary on AI. The worry I have is in the late 60s and then throughout the 1970s, the sort of mainline humanistic critique of AI emerged from phenomenological quarters. Hubert Dreyfus was he's a great reader of Heidegger and Husserl, an excellent philosopher in his own right. He was actually asked to create a report on the status of AI, which I think he called Alchemy in 1968 or 69. And he then published this very influential book called What Computers Can't Do. And one of the things he was saying was, look, computers are not in a situation, they're not like in the world in the way that Heidegger thinks we are in the world. They don't have a life world. They don't exist in a situation. And he did make some room actually for the idea that like neural nets, the modern deep learning methods, like the ones that we're seeing now, might be more flexible, they might be less formal and so on. But the formality question sort of remained at the forefront. And my worry about that line of thinking, there's a lot of value and a lot of interest in Dreyfus, is that it basically says, think about the title, what computers can't do. It basically says, here's stuff humans can do, here's stuff computers can't do, here's maybe some stuff computers can do that's not human and so on, right? It tries to draw a bright line between the human and the machine. And I'm perfectly comfortable drawing that line in many, many places, but not when it comes to formal systems. And so if you take something like language, which is clearly both formal and informal in different respects, you kind of can't draw the line in advance. That's my problem with that. So should we readopt the notion of a life world? It's probably valuable, but I don't think it will explain these systems to us by itself. So that's where I end that article too, is kind of arguing for a semiotic approach, because it's like, what are these systems except signifying systems? Systems that signify what things are, even if they're wrong, and where things should go where, in the case of logistics or bombs or something like that. And that type of signification certainly contributes to our life world. I think that theory is very serious in that way. But more locally, I think, how do those things get generated is kind of the question that I think needs to be answered. And I'm not sure that answer really can come from mechanistic interpretations within AI or, from the point of view of cognitive science. I think we have to answer it.
Brilliant, thank you. I think we're going to open now to the Q&A to the audience.
Yes, so thank you so much, Leif and Audrey. We have plenty of questions lined up, but please do keep adding your questions via the Q&A box at the bottom of the screen, and we'll try to get through as many as we can. So the first question is from Anne, who says, can you foresee a future where the Internet of Things, capturing ubiquitous sensory data, visual, temperature, audio, etc., will supplement training data sets to a degree that the AI models will break out of being so solipsistically text bounded?
Yeah, and I think there are already experiments going on in this way. There's somebody, I'm not trying to promote NYU, I promise, but there's another figure here at NYU, Brendan Lake, who has attached for a couple of years now head cams to babies in Australia, and is trying to see if large language models can learn as the child does, basically to see whether they learn more quickly if they're not trained primarily just on text corpora, but instead are also trained on some kind of like grounded information in that way. The thing that just strikes me about these experiments of that kind, because I think we will get them. I think we're going to get hybrid, they're calling them multimodal systems. I think they're going to roll out fast. I think that things are going to change in the next 10 years in kind of a really weird set of ways that probably are not predicted by our science fiction expectations, but whatever. I do think that we're going to get all kinds of hybrid systems like that. Right now, it looks like most of those systems will at least involve a large language model. So there's this kind of burning open question about what that model actually does. Nobody really has good answers for that question. Yeah, keep LLMs away from babies, someone said in the chat. I totally agree with that. So as we get these results, I think we have to keep asking, like, what's underlying, what's underneath the model, right? Because otherwise we get this problem, which is that we just say, well, these work pretty well, or they work better than X. There's a benchmark problem where it's like, yeah, but we don't really know why they work that way. Like, their greatest success to date is the protein folding problem, which, if it got really actually solved for scientists, would be a massive, massive sea change in the way that we understand the biological universe, because protein folding is at the basis of like all of genetics and just carbon-based biological entities. It's an incredible and super interesting problem. But the step that's been made forward there is only prediction. So it's been solved, but not for us. And that puts severe limitations on what that means for science, right? Because we're able to predict certain things, maybe we're able to, it's powerful, but a high dimensional model that's powerful isn't necessarily an explanation. Without an explanation, you don't know where you want to use it, you don't know where it's safe to use, and so on. So I think that explanatory level still remains like super important. And I don't think that hooking these systems up to the Internet of Things is going to lead to explanation by itself.
Great. So the next question is from Tyler, who says, thank you for the very clear and engaging talk. While I'm rather convinced by the need to delve into structuralism to account for what is happening, I'm wondering how a sociogenic or activity-centered approach, i.e. Leif Vygotsky and successors, could complete the picture and account, or perhaps give a counter-argument, for how meaning is developed through the social interactions and instruments that mediate experience.
Yeah, I mean, I think structuralism is sociogenic. They don't use that word, but I think it is. I don't know about activity-centered. What I don't think is that these models actually capture the way that humans use language. I think they capture aspects of the formal aspects of language. Sorry, aspects of aspects. They capture formal aspects of language that exist between and are mostly and have to be deposited, at least in the current models for the most part, into texts in order, and so they don't capture as models what linguists call the pragmatics of language. They don't capture larger discursive things that we do, dialogue and so on. They do that by actually interacting with humans with something called reinforcement learning with human feedback, and they do that poorly. they have terrible personalities, you know, ChatGPT is just sort of obsequious and boring, whatever. So sociogeny is like a super interesting way of thinking about the overall thing, but I'm not sure that the current methods are actually capturing like really dynamic social processes of those kinds. This is the only worry I have about that. But otherwise, I think, yeah, let 1,000 flowers bloom. There should be many different humanistic approaches to this.
Great, thank you. And Audrey, do jump in if you want to add anything to any of these answers.
I wanted to ask quickly, Leif, and as we've seen very recently again in a certain group that will remain will not be mentioned here, can we really, you know, these systems are perfect to predict, but can we really, do you really think we'll be able to lift the veil to understand how they work, gain an explanation of them?
Yes, it depends on what we mean by that, right? The analogy that gets constantly used, so there's a whole history to the like probing them to see what's inside. There was a popular article a couple of years ago called a primer on Bertology, because BERT was one of the models, and then there was a sort of like attention to like, the new one is Anthropic, has this thing called mechanistic interpretability. There are earlier versions of that just probing. But the idea is always like go into the system, find a layer of vectors, see what the layer is doing. So what you do is I mean, they're not black boxes. You can just print anything. So you just go in and you just kind of say like, what's happening right here, print it all out for me. And then what they'll say is like, here's an inductive bias for grammar, or here's an inductive bias for inductive biases or something like that, right? And this is both inspired by, as the whole model is, neuroscience, and it imitates neuroscience in its procedure, minus all the sort of goopy stuff that's, you know, you have to deal with in the brain. And then it also imitates all the problems with neuroscience. Like neuroscience doesn't know what its object is. Is it the brain or is it consciousness? And I think a similar problem is right here, which is like, is the object of the mechanistic interpretability meaning, which is what the systems actually produce? I'm sorry, I'm just going to say it like that. Or is the object of the interpretability vectors? Because if it's vectors, yes, we can absolutely do it at that level. If it's meaning, then we need a theory that guides us from the input to the output and in the whole social situation in which that meaning occurs. That is never going to get done in AI circles. I just don't believe that it will get done the way that AI is motivated right now, the way that it's scaled, the way that the incentives work within AI. So I think it can be done. Whether it gets done will just be a question of whether it'll be an institutional question, whether we can, whether humanists and philosophers can put together enough sort of like constructive, even if we disagree with each other, sort of attention to these problems in order to get an explanation that is satisfying. And I would say the thing that is super interesting is that there's almost no philosophical problem that you can't see here, right? At least in negative. So anyway, yeah.
Great. So I'm going to
bunch
pose
of other questions. I'm sorry if I didn't mean to take too long with these answers.
No, that's fine. So yeah, we've got quite a few, but I'm gonna pose the next two questions together because I think they may be connected.
Okay.
So the first one's from Bummy, who says, "Can you say more about the relevance of the Nigerian word?" I presume that's delve. And then also from Laurie, who asks, "How much of the increased abilities of the generations of GPT is a result of using increasingly large training databases, and how much is down to other causes, and what might those other causes be?"
Yeah, Laurie's you're putting your pressure on a really super important and interesting point there. I mean, I think the delve example is one that people have sort of passed over as a curiosity. This is one of those examples of like, hey, here's a culture thing. Nigerians use delve. You know, maybe that looks quaint or serious or whatever from some cultural perspective, but who cares? It's just some word, right? Well, the value of that word, the actual meaning of that word, not what it signifies, not that it means to go into something, but its relative value in the linguistic system is being affected by the way that it's been, in this case, the presupposition is that it's been reinforcement learning fed back into the system so that ChatGPT overuses it. And that then creates one of these meaning effects that I'm talking about. the model versus scale question is a totally open question. We simply do not know. Basically, simplifying a lot. Most attempts to model language most attempts to model language within deep learning have either been of a kind that just sort of distributes the words near each other and says, like, how often do they occur together? The distribution thing I was talking about. Or there's some sort of model that says, like, the recurrent neural net, which was proposed in the 80s and then, made some successes in the last decade or so. It had this feature, was like, well, one thing we know about language is that we sometimes take the sum of our language and we put it back in and then we use it again. There's a recursive aspect to language. So they tried to realize that at the model architecture level. And that turned out to create all these problems of, like, forgetting. And there was kind of a mess that evolved over a long enough period of time, because there are things that happen in a conversation, like we're talking for an hour here, right? You could say, like, right now I haven't said unicorn since the talk, but 30 minutes ago I said unicorn a bunch of times, so it could become relevant again right now, right? You can think of examples that go over very long distances of text. And it turned out that RNNs, recurrent neural networks, couldn't do that kind of thing at the scale at which they were being trained. Now, the transformer architecture opened that up. It sort of brute forced an openness. It took all the structure, the presumed structure of language, out of the algorithm and allowed it just to create this each to all matrix, which seems like that's what's driving the change. But there is a constant suggestion now, maybe that's not what's driving the change. Maybe it is just the fact that we went from training on millions or hundreds of millions of tokens to trillions, which is a massive sea change. When you get to trillions of tokens, so we don't know. The problem is, of course, you can't just run these, it took us like $1 billion to train one of these things. So it's not like we can just do lots. This is another reason that the explanatory science thing is a little bit wonky as a notion. It's like, yeah, we could run differential experiments, but training one from scratch is so expensive that we're kind of left in this middle space where we're just kind of guessing about that. But I think Laurie's asking a really important question there, because I do see people saying in the AI space, like, maybe, some of these older techniques will turn out to be even better than transformers. And that would be super interesting. And I think we'd have to sort of look at why that would be if it did turn out that way. Oh, there's a lot in the chat now.
So I'm going to pose another two questions together now, because they're both on structural linguistics. So the first is from Dean, who says, can you address how Saussure's parole lang fits within or speaks to AI language models that you've described? And how does speech act theory relate to the AI language model reality that you've described? And the second one is from Michael, who says, if we push the structuralist paradigm to its social systemic end, we may find ourselves at a Luhmannian precipice. Luhmann's famous tautological provocation is that humans can't communicate, only communication can communicate. Do you see systems theory as providing a theoretical corrective to the Leibnizian and now Whiteheadian paradigm in AI discourse? If so, how and why?
Well, first of all, I think you should use the phrase, you should trademark Luhmannian precipice and use that in some way. That's a wonderful phrase. Let me take the first one first. I haven't really decided. So Saussure has these three categories. There are all these dichotomies in Saussure, but there are actually three in this case. There's parole and langue, and parole is speech, the utterance. Langue is the language as a system or code, right? And then in between the two is like the usual way that you use language, which is partially codified, but also comes mostly from your like immediate speech environment, which is called langage. It's difficult to translate that distinction. I think that the underlying models are learning langue, basically, because I think that we're passing so much language through them that they're gaining access to structure that is far above the level that any structuralist, any statistician, any Chomskyan ever really imagined that they'd have access to. And the structure that's coming out of there has to be, I mean, it's a very strange thing, but it's sort of exactly what Saussure predicts, which is that the live stringing together what looks like utterance of something like an article that says, hey, they found unicorns in the Andes, right? But that makes sense linguistically, if not semantically always, then that this thing is like coming from a conditioning of the formal system, language as a system. And that's kind of the idea of structuralism in Nietzsche. Like that's the whole notion is, and this got, of course, like recoded with Heideggerian language and post-structuralism. You're born into language. Language is the prison house. Like, it's like, you're thrown into language or whatever. I don't need any of that metaphor. I just want to say we have that larger thing that's like sort of compressing into the local values as they're produced as utterance. That's how I see that first question. I'm not really sure how to answer the second question. Only communication can communicate. I'm struggling to think of a place where Luhmann takes language seriously as a medium or a system, like as an independent medium or a system. There's been a series of sort of like skirmishes between Derridians and Luhmannians over time, where the Derridians would say, hey, systems are not really quite systems in your sense. Systems undermine themselves as systems or whatever. And then Luhmann has this like supra-systemic perspective. I mean, I'm generally on board with the idea of observer systems operating in that way. A lot of Luhmann's language in that just comes out of cybernetics, second cybernetics, biological computer laboratory style stuff. The history that goes back to McCullough and Pitts, and which actually eventually goes back to the founding of the neural net. Only communication communicates. I mean, that could be another one of those metaphors, like, only communication communicates, only language speaks is something you can imagine a post-structuralist saying. The thing that I'm saying a bit in the book, not to give too much away or to piss people off in advance or whatever, but like I do think that like that type of stuff has the tendency to be diagnostically valuable, but less analytically valuable. And local attention to the way that language works in this super banal way, that computation works in a super banal way, just like attention to signs in this way, was the tendency of structuralism. So the post-structuralists, and I'm lumping Luhmann together with the post-structuralists there, I'm sure Michael Miller will be very upset about that. It's like there's a tendency for that to be, I think, as Audrey said earlier, like there's a sort of like, here's a place where it looks like, wow, it really looks like the world that Baudrillard predicted, or the world that Barthes predicted, or the world that, but do we have there an analytical tool necessarily for doing what we need to do now? The answer is not always yes. That's not to say, I have a lot of respect for Luhmannian sociology. I can't think of a way in which it helps us to parse the problems of like local problems of like system and meaning in language that I think we need for these particular algorithmic models.